Hi, good morning. Is that better? Yeah. Great. Thanks. So my name is Mark Templeton, and I'm representing SABIA, which is the Southern African Biogas Industry Association. You'll see the map behind me representing the 9 countries in Southern Africa. SABIA is a non-profit organization. It was started in 2013 and has a list of members that sign up every year, and the main goal of SABIA is to promote biogas as a renewable energy source in Southern Africa. Just to give you some context about what's been happening in Southern Africa over the last couple of years. When talking about the just energy transition, moving away from fossil-based fuels to renewable energy, it's been dominated by the 3 renewable energy sources you see on the screen: wind, solar, and hydropower. Southern Africa is dissimilar to Europe in the fact that we have large land masses, we have great solar irradiation, and we have onshore wind, as well as obviously large lakes like Lake Kariba, where Copora feeds most of Zambia, some of South Africa, and Mozambique. Saying that, we think that there are a number of drivers which will help hopefully increase the adoption of biogas in Southern Africa. And those drivers are these 4 little pictures that I've got on the screen here. The top left one is a gas molecule going off a cliff. And the main reason for that is that natural gas in South Africa, in Pretoria and Johannesburg, as well as Sasolburg, probably the most heavily industrialized sector of Africa alone, is fed by the Pandamani gas fields in Mozambique. And those gas fields are running dry. Sasol has already told its market and all its customers that they'll no longer be supplying LNG, liquid natural gas, to them in 2027. As a result of that, the industry needs to make a plan, whether that's floating LNG to Richards Bay or Durban and trucking it up, or creating biogas as an alternative fuel source. The next little picture is the biomass, as a world biomass map. And as you can see, Southern Africa and Africa as a whole is very fortunate in the fact that we have arable land, a high rainfall, and able to grow a lot of biomass feedstocks for biogas. The power lines depicts the fact that in Africa we don't have a stable supply of electricity. There's a lot of Africa that isn't electrified yet. Countries are running like crazy, as the rest of the world are, to try and ensure that those power grids are actually linking up to renewable energy sources. The nice thing about biogas is that we can actually start creating islanded solutions. If we create enough biogas and put it through a biogas genset, a gas genset, we can actually start looking to create a firm power supply in these villages and in these towns where there is no access to electricity at the moment. Building 400 kV lines is expensive, it's time consuming, you have to get servitudes, you've got to get the right to build those lines across farmers' lands. That is circumvented with the biogas solution. The last one, legislation. Legislation is obviously depicting the fact that Africa is catching up with Europe when it comes to putting legislation in place to ensure that biohazardous materials like cow manure, chicken manure are properly managed. And the best way to manage those kind of feedstocks is through a biogas process. Take it out of the oxygen, take it out of the air, don't spread any bird flu, foot and mouth, etc., etc. The other driver is obviously CBAM, so that's your carbon border adjustment mechanism. South Africa and Southern Africa produces a lot of metals, as you all know, steel and aluminium being one of them. ArcelorMittal, Columbus Steel are big enterprises in South Africa that use a lot of power in their arc furnaces. We could probably produce biogas to provide quite a bit of that power to smelt the steel as well as aluminium. The other one is obviously SAF, Sustainable Air Fuels. There's a mandate for us to start blending sustainable air fuels into aircraft that fly us over to Europe to avoid the taxes on those Lufthansa flights or whatever flight that you're using to fly into Europe. So that's another driver for us moving towards biogas. Enablers for biogas in Southern Africa, commercial banks and project finance. As I mentioned earlier, Southern Africa has put down gigawatts and gigawatts of wind and solar power. We've got a very strong banking system in South Africa. We've got very strong commercial banks. Project finance has been done for years, since 2009-10, when we first started building large utility-scale wind and solar farms. So we have the legal teams, the professional banking teams. They're able to sort of project finance the bigger biogas plants. So that's pretty self-explanatory. As I mentioned earlier on, we grow a lot of vegetables and fruit for Europe. A lot of wheat, a lot of sugarcane. So there's an opportunity to use those spent or wasted feedstocks and put them into a biogas process for a biogas or ethanol, methanol production. This is quite interesting, and I've come across quite a few different businesses in Southern Africa that are looking to specifically grow feedstocks for biogas. Obviously, the picture on the left is a cactus in Namibia. Namibia is very arid. There's quite a few mines in Namibia. Again, there's no grid lines to these mines. The one thing that's growing there pretty quickly is cactus. It's quite easy to grow that at scale, produce power for running the mine, or the gas, ethanol for transporting those aggregates to port, etc. The other one is Napier and vetiver grasses in places like Zambia, Botswana, Mozambique, high rainfalls, arable land that isn't being used and won't be taken, it's not being used in actual fact for food production. We could grow vetiver grass and Napier grasses for biogas production. Also, once we've containerized it and cleaned it out, we could actually swap out LPG. So it'd actually be a lot cheaper to put biomethane into gas tanks and then swap that out for LPG. You wouldn't have to then transport LPG from port through land into landlocked countries. There are operational biogas plants in South Africa. We've got massive landfill sites. One of the other reasons, which isn't on my earlier slide, is we are running out of space for landfill sites in our big cities. They're all being used up. So again, the legislation is stopping in the Western Cape, in the Cape Town area, not allowing people to put organics into landfills anymore. Robinson Deep is a 5 megawatt landfill gas site, which produces 5 megawatts of gas power for Eskom, our state utility in Johannesburg. There's also a cow manure biogas plant called Bio360, which has been wheeling power into a BMW facility in Pretoria for the last 10 years. That's 5 megawatts again, and that's going to be upgraded to another 10 megawatts. This is quite a good story. Cape Town Biogas is a biogas plant that takes spent food stocks and waste products, mainly from vegetables and fruit in the Ceres Valley area. They're producing 600 gigajoules of biogas, biomethane every day. They're liquefying the CO2, and there's obviously organic fertilizers coming out. I think what's nice about this story is that this should be replicable across the other big cities in Southern Africa, Harare, Maputo, Lusaka, for example, and that's not been done at the moment. So I think there's an opportunity for these countries to also start implementing large biogas plants. And that's it. Thanks so much. I can field some questions if there's any questions.
I'm next.
Experience. You see, the smaller ones is containerized, and it's very, let's say, the small biogas plants are very difficult to operate because you cannot afford sensors and all of this. What you can do with the big ones. The right picture is in Kenya at Lake Naivasha, is a 2 megawatt plant, and that's it. So we built nearly all over the world except Australia and US, and more than 50 biogas plants in 14 countries already. So the challenges, before I go to the solutions, financing institution, I used due diligence projects to death. Means again and again and again. So until it's not profitable anymore. And this quick money or shortest term ROI attitude doesn't work with biogas. Let's say it's a power plant, and sometimes it takes 10 years to recover the money, and this is not what African, or let's say international investors want to do. They want the money back in 1, 2, 3, 4 years. And on the other hand, no one knows that biogas is highly profitable in the food industry. I calculated a project in Ghana, payback 2 years, replacing HFO, electricity, but it never happened because the institutional owners of this fruit juice factory is from London. They were not interested, and the Brazilian operators, they said, oh, we don't care, we don't want to have an additional operation. And there is still only basic knowledge available, and more or less zero practical knowledge with bigger biogas plants. They still build their fixed dome biogas plant, means the Goba biogas plant from India is just enlarged. And they don't work. And no one heats the biogas plant, the digester. I saw a clogged digester in Nairobi, and when they're in the ground, then they had 18 degrees soil temperature. No biogas plant works with 18 degrees. That's it, and no one cares about this. And maintenance is key with biogas, and cheap spare parts, as I said, spoil the performance. If they need a spare part, they buy cheaper from India or China. Even they have European genuine equipment, and then it goes down. And another thing is the wrong African people are trained in Europe. They train the academics, and they don't want to have a black collar, a blue collar. We have to train the real people who really operate the plants. And I had one for training, Paul from Kenya. He's a fabulous guy. He then operated for 3 years in Europe. He even operated biogas plant in UK and all of this. They are really good, but he's an electrician, has not a bachelor in bullshit or something. So I'm an investor, so I'm not one of the nice guys, and I'm an entrepreneur. I'm one of the bad guys who really point to these things. And what we learned is they choose the operators by families, not by skills and commitments. This is complete nonsense. And then they failed. That's a problem. Okay. Now, we learned from them how to approach this. Kuram, this is now for you. Then how to assess a project viability in 10 minutes with only 7 questions. This is what we do. And first, do you have a private buyer who buys all the produced electricity? You mentioned already the mines in South Africa or Southern Africa. These would be the perfect buyer. Or a fruit juice factory where you produce the electricity and a lot of heat, and you use it for the it's not sterilization, pasteurization of the juice. That's it. So don't sell to any utility, because you never get your money in Africa, even in Southern Asia too. Then, does the buyer pay more than 10 cents per kilowatt hour electricity? So in Ghana, we would have had competed with 28 cents, easy, they didn't want it, but 10 cents or less than 10 cents, you can produce every kilowatt hour with the biomass you have in Africa available. That's not the problem. Is the feedstock for free at the site or very low cost? That's it, because when you have to buy the feedstock, finally, and from the farmer, let's say it will kill your project because the farmers will raise the prices. We saw this with paddy or rice straw biogas plants in India the last years. So the paddy straw is not profitable anymore in India because the farmers want to charge so much money and the investors don't take the paddy straw. They still burn it. And that's it. And does the feedstock come from maximum 3 sources? Not more. You have to handle it. If it's more people, it's a logistic nightmare. And then, is the feedstock secure for minimum 5 years? It must be secured for 5 years. Then you have to pay back, and you have the money out when there is a good profit project. And then even if they don't deliver anymore, the project is bankrupt, but you are not bankrupt. It's very important. Another thing is, can you use the heat of the CHP and replace fuel? If we can do this, then most of the projects are a no-brainer. They work economically. That's the point. It's so easy. So electricity plus heat. And number 7, is there a market for fertilizer, or can you use the fertilizer? When you have this fruit juice factory or tea plantations and all of these, they need the fertilizer by themselves. So it's a big income source. It pushes down the ROI, let's say, to 2 years or even lower than 2 years. It depends on the price of the fertilizer. And that's it. So this is the standard we built. And so if you have a question, just contact me. And then, yeah, that's it. If you're interested, you can have this presentation, or I have a small MP4 for this, and then you can get it. Thank you very much.
I don't know. Who is next? Let's see. It's a wild game. Hi everyone. Very happy to see some people here, and thanks for coming to listen about biogas for the African market. My name is Andreas Kangari. I'm the global product manager for Sistema.bio. Half of Africa population, mainly workforce, is actually working on agriculture, mainly in primary production. And out of 80% of all these farmers are smallholder farmers. They are actually serving and producing most of the continent's food, but still these people are living in poverty, and in the recent years they are also threatened by climate change. They are facing challenges. Some of these challenges is, most of them, they are still relying on cooking with firewood and charcoal, which means they are exposed to unhealthy kitchen conditions. And the rest of the percentage, they are actually relying on important fossil fuels, such as LPG and kerosene. Another challenge is that 45% approximately of the farmers' expenditure goes to important goods such as fertilizers and pesticides. Sistema.bio started in 2010 with the vision that the world, every waste in the world can become a resource, and farmers are empowered to be independent, productive, and the change makers. We came up with a very simple solution for these small farmers in the rural areas around the world. where it's a simple digester, and with the use of it, farmers can get two things, biogas and biofertilizer. It's very affordable for the farmers that we are working on in the market. It's prefabricated, very easy to install, can be installed in a matter of a couple of hours. Very simple to operate and maintain, so any kind of farmer, no matter what is the expertise and the knowledge, can very easily understand how to operate it. It comes in different sizes, so it can serve any kind of farmer depending on the size of waste and animals they have on the site. Basically, having this on the hands of the farmers, they are actually having the power to generate their own energy in the form of biogas, where mainly the farmers that we're working on, they use it for cooking, and several others, they use it for water heating, they use it for mechanical mills running motors and engines, so they can increase the productivity of their farm. They also produce the bioslurry, which is also known as digestate. This one helps them to reduce their imported chemical fertilizers, which is sold to them at very high prices. And also there was many other scandals, political scandals, for example, in Kenya, that they were not really selling them even the real chemical fertilizers that they were having on the label. So they are empowered. They can be more resilient, and they can actually have control of their farm's sustainability with this product. Except from the two main benefits, they have extra co-benefits. They no longer have to be exposed to all these smoky kitchens because now they don't need to use firewood, they use biogas. It's estimated that people can save up to 21 days annually per year because of non-exposure to unhealthy pollutants. Also, another SDG that is very strong on that, our system, is the gender equality. Women that are the majority that spend a lot of time in the kitchen now can actually spend less time, because they spend less time in collecting wood, they spend less time for lighting up the fire, so they can actually free up to 2,085 hours per year that they can spend in more quality time, like education or any economic activity. And the final important benefit is obviously the climate action. By having these systems, you reduce the super pollutant methane emissions that are normally there because of poor manure management, and also the reduction of chemical fossil-based fertilizers. We give 10 years warranty to our reactors. We want our clients to be able to use this system for a long time, and that's the beauty of our system. It's very simple and it's very durable. We have 7 different sizes of single reactors that you can see here. It starts from 2 cubic meters per day to 14 cubic meters per day of the system, and they are also modular, so you can stack a couple of them together if you want to get more production. So based on the experience we had in the last 15 years, mainly we categorize our farmers into 3 categories. The main first category, which is the biggest chunk of our installations, is smallholder farmers. This is farmers that they have 2 to 5 cows. This is the majority of the farmers around the world. And this is the system that is more sold and installed in Sistema.bio. Then we have the more entrepreneur farmers. These are farmers that they have approximately 5 to 25 cows. These are farmers that they are pushing more to enter into the market more strong. And then we have the more market integrated farmers, let's say big farmers, 25 to 100 cows. And this is, as you can see the photo there, this is the more productive systems we have where we stack together our reactors. To make use of the biogas, we also supply them with our own appliances, basically for cooking needs, as you can see in the top row, and then also for more productive use applications, such as swine farmers to heat up the piglets or the chickens, then the water heaters for heating up water, and also running engines that helps in the farm, like shaft cutters and shredders. In order to measure the impact of our projects around the world, we have also a smart biogas meter. This is installed directly on the gas line. It's a very affordable meter in comparison to all the industrial meters that are available. Just to give a number, this costs approximately $100. If you buy one from industrial plants, it can be $5,000. So this is a very simple tool that we use in order to measure the performance of our digesters. And this is also a DMRV tool that can be used also for carbon reporting purposes. And then finally, bioslurry, which closes this loop and makes a circular solution. The bioslurry is a very big benefit for the farmers. It regenerates the soil, improves the soil health, and we have farmers that have reported that they have reduced up to 30% their chemical fertilizers. It's in most of biogas plants, normally this is always talked as a secondary, but this thing is actually coming very big, and we are very happy to see that more and more of our farmers actually start focusing on this instead of the biogas. We have two examples of projects that we started last year, one with Danone in Morocco and the other with SNV Ethiopia. Both these projects, their focus is on the digestate, on the bioslurry, because they want to give the ability to farmers to regenerate the destroyed soil of those years that it was very badly handled. It really is very promising, and it's a way actually to reduce also the Scope 3 emissions in the value chain of the agri-food industry. We have several partners that they work with us. Some of them is Nestlé and Danone, as you all know. These companies, and also Amul, very big dairy industry in India. They work because they actually want a solution, a quick solution to their small farmers to decarbonize the value chain. And this solution is a very easy way to give the ability to farmers to decarbonize their operations, and also giving them also a lot of social impacts. We also have a few other projects. Majority, sorry, I didn't mention it. The majority, as you understood, of our market is farmers, mainly dairy farmers. We also work with a few poultry and swine farmers, but the majority is dairy. But we have also done projects in the past in some other kind of waste, such as food waste and human waste. This is not the primary focus, but it's very interesting also projects for us that we carry out. So we are 15 years in the operations. We have plants in 35 countries around the world. We have our main offices in Mexico, in Kenya, in Colombia, and in India. And each of these countries is responsible for the continent. And we have, up to date, installed 148,000 digesters around the world. I think there is no other company that has achieved as many farmers as Sistema.bio. This is really beyond what, like an industrial biogas can achieve. And this is the market of Sistema.bio. This is, we are helping the small farmers, which is millions around the world, to actually have a biogas solution in their hands. In Africa, we have very strong presence. We have currently 6 active African countries. Sistema.bio is based in Kenya, but we have local partners that we work with in order to give our solution to the local farmers. We have currently in Uganda, in Ethiopia, in Morocco, Malawi, and Zimbabwe. And we have also done projects around Africa in the past years in the rest of the countries that you can see. Up to today in Africa, we have more than 15,000 digesters installed in these 16 African countries. We go across the whole value chain of a biogas plant, which is we manufacture our own digesters, we sell, and we also help finance the digesters to the customers, to the users. This is either subsidizing them through companies that invest on carbon credits, or through agri-food industries such as Nestlé and Danone, or we collaborate also with local banks, especially in Kenya, where they support the farmers to get their solution subsidized or in different paid terms in order to give the possibility to have access it in the way they want. Then we install, we train, we monitor the digesters across the years. We offer after-sales service because we don't want to abandon biogas plants and good luck to the users. We are there till the end. And with the feedback we are getting from the farmers, we also have a very strong R&D team where we further innovate and improve our products. And we are not saying it that farmers love our products. We have external companies like 16 Decibels where they do annual survey to our farmers to check the satisfaction of our farmers, and the results you can see, they talk by themselves. We have 72% that they actually say that the health condition in the kitchen, in their house, has very much improved. Also in the right, you can see more perspective from women experience that 74% they are actually confirming that they spend less time on the cooking activities, and this is basically because of faster lighting up of the fire and no time needed to collect firewood like before. I'm not alone in this company. We have a very strong team. We have 900 passionate individuals around the world that they help to install, to sell, to do the after-sale service. It's a very multicultural team, and this is the power of Sistema.bio. We have experience in so many countries for the last 15 years. We understand the difficulties of scaling up, and we managed to scale up at a very high rate in the last years. And the beauty is because of this team, which is a very international team, different cultures, different language, but we are all together. So yes, that's me. I'm happy to have any questions now or later. Please, you can find me also in stand C18 for any further questions. We are very happy to collaborate with people that they want to also support this industry and the local farmers. Thank you.
Thank you. Good morning. Thank you for your presentation. My question relates to the cost of installation of your digester. Have you a range of this cost?
Hello. Yes. Thanks for the questions. So basically, our systems ranges depending on the country, but to just give you a bulk figure, the smallest system that we have is around $400 to $500. So you can understand how cheap is our actually having access to biogas if you compare it to a more industrial scale biogas plant that can cost millions. Obviously, it's different markets. We are giving a solution directly to the house of the farmers, and this is the range. Obviously, the larger the digester you have, the larger the cost increases, but it can start approximately to 400 to 500, goes to 600, 700, and so on. Thank you.
Thank you for the presentation. It seems low tech, which is good, but how do you make sure there is no methane leaks on the products?
Yes. So with the tool that the smart meter that I have shown before, there was also one point, but I didn't really mention it. For the time, this tool also detects if there is methane leaks, because it can identify when the digester has reached the maximum pressure, and means if the pressure stays stable, it means that you are start leaking. So you can also measure and identify which of these digesters are actually emitting methane, because they are actually not using the biogas as it was supposed to do. So yeah, thank you.
All right. Good morning, everyone. Are we still awake? Are we still all right? I don't see a smile. I've seen a few smiles. I just want to make sure we're still good. Great. As my colleagues mentioned, thank you for being intentional with your time, for making a conscious decision to come sit here and listen to all the projects that we are exploring on this wonderful continent of Africa. There's been too many studies of how it is the dark continent, but the conversations that are happening here, the conversations that will happen in June when Bio360 moves to Johannesburg, will show you that there are people who are trying, who are striving, whether it's on a small scale or on a large scale, but things are happening, things are moving. So my name is Dr. Gamuchirai Mutezo, and I'm the founder of a company called Madam Waste. There are many things that we do, but for the purpose of today's conversation, we'll be unpacking decentralization of biogas systems, specifically in urban areas, so that we look at this concept that we have called urban energy hubs. Oh, there we go. Right, a bit of a technology glitch there. This has been painted by my colleagues, and I want to emphasize on why are we talking about decentralizing biogas in African cities. My stance is a bit different. I'm looking at urban waste. Our cities are rapidly urbanizing. Every other report you're going to read will tell you that African cities, population, waste, energy demand, everything is just increasing. So with all of these increases, where on this planet Earth is our urban waste supposed to go? Because we physically do not have the land for more landfill. Yes, the conversations are happening. Some are engineered, which is fine. But in the meantime, while all of this rapid urbanization is happening, what must happen to the waste? What must happen to the organic fraction of this material? And this is where we're saying, let's look at urban energy hubs as a way to decentralize energy. Whether you're going to look at it from a biogas system or from a biochar perspective, composting, whatever the case, that's then the beauty of organic material. You can have a variety of energy outputs. It's just a matter of customizing that to the type of organic material that may be identified in that urban area. Oh, by the way, did I tell you that there's going to be a quiz after this? Yes, so you better be listening. And of course, something else that motivates these is the lengthy processes of applications, submissions, licensing, and so forth. So for those players who are already in the commercial and industrial biogas space, kudos, congratulations, keep at it. There is equally room for small and medium-sized technologies to be featured, especially in urban areas. And that also presents a beautiful case for what a circular economy looks like. All right, so some 2 years back, I got frustrated. We have a consulting side to the business. I got frustrated because you explained to a client that this is what you can do with organics. It's a beautiful resource. It's stunning. We're like, yeah, I get you, you know. But you realize that some clients would not pursue an active decision because they could not quite conceptualize what does this thing look like. Yes, they've traveled to Europe and Asia and seen the big, wonderful technologies, but they're not able to relate to it. And that's where it kind of kicked that, okay, there's an opportunity for some element of social engineering because some of these things start with the mind. So we said, let's set up our own waste valorization demonstration site, which is located in Pretoria. So the location is quite key for us because we are based at an agricultural research council where the production of livestock is the primary research component. So it becomes a wonderful relationship where on one end we've got feedstock in the form of animal manure, and on the other end, because of the location, we can access 3 metropolitan municipalities, and that means 3 major suppliers of urban food waste, be it agro-processors, retailers, and even households. There are some entrepreneurs who play in the collection space, but they wonder where can we take this to, what can happen, and that's where we come in. So when we set up this demo, we said, you know what, let's look at a relatively small technology system so that people can relate to it. The moment you can touch, smell, feel something, it becomes a mindset shift. You start to make different decisions, whether you're sitting in corporate or in a local municipality or in a large retail space. These are then the things that we saw as an opportunity to shift the mind so that the decisions we make either to, I suppose, dispose the material or ensure that projects of this nature can be financed or projects of this nature can be franchised, it becomes easier. Sometimes you say no because you don't understand, you're not able to relate to it. So what we have at the site are 2 main technologies. The first one is an in-vessel composter, and the second one is the small-scale biogas system that you see, which is made in South Africa. It's 1.5 cubic meters. And the gas we use on site also for demonstration purposes, but my team and I, we cook on the site. We make our teas in the morning, we make our food, and the whole 9 yards. So when we have guests coming to see, we actually show them, and it really shifts the mindset, like, oh my gosh, this is so cool. And we know, okay, we're onto something now, because we can start to see more interest within the space. So in this picture, that's just an example of the kind of, let's say, skills development that comes with this. This young gent, he's got an environmental background, but not necessarily waste management. He came to us as a volunteer and is like, this looks interesting. But he's the one who now tells me what's happening. Doc, I want to do this. I want to explore that. So if you have young people whose mindsets are being shifted to see the beauty of organics and the opportunities across the value chain in spaces such as biogas, then our future is certainly looking a whole lot more different, because these are the decision makers for tomorrow. It comes to the point you mentioned earlier in terms of the wrong Africans being trained in Europe. So demonstration activities such as this are providing a physical space for artisans or even academics, let's put it like that, to be intentional and be part of the solution, because this is in your own backyard. You spend 4 years at university and then what? No. So these are the kinds of opportunities that we also showcase at the demonstration site. So this picture is really just telling the story that I've mentioned in terms of the skills development that come with it. The lady who is mixing the cow manure, that's the first time we were filling up our digester. She also has an agricultural background. She came to the site and like, oh, this looks interesting. But she's the one who works together with the gentleman, and they're the ones who tell me, Doc, this is what we're doing. This is what we are doing next week and all sorts of stuff. So again, it's encouraging to see that the biogas industry can create such opportunities for skills development and also inspire an entrepreneurial component. Now, whether it's entrepreneurship across the entire value chain of organic waste valorization or a certain component, hey, whatever the case, there are some things that you can do and also generate income. Right, so the team comprises mainly of ladies. We do have guys, but it's mainly ladies, and I'm the only one who actually has formal training in waste management. The rest of the team, it's really just curiosity, interest, and willingness. And that, for me as a founder, is supercalifragilisticexpialidocious. When you have a mindset of individuals who want to be part of the solution, it makes it easier to disseminate such technologies. So the key lessons from this pilot, well, what happened here was we received some cheese waste, and because we hadn't received the chemical composition of this particular cheese, we put in a bit. The gas just produced overnight, and before you knew it, it went kaboom. So this particular picture, we were removing the digestate out of it so that we can restart the process. So we did not clean, because the microbes are still quite important. That digestate, we just dried it up and tested it in our food systems hub. So we've got an indigenous food systems center because we're showcasing the entire process of a circular economy. Right, so feedstock quality as well as the animal health directly affects. So given our location at a livestock production center, if the animals are being vaccinated, they've got antibiotics, we did see some impact in the gas generation. Correct slurry ratios are certainly essential. So we use a 1-to-1 method. So 1 bucket of cow manure to 1 bucket of water. In terms of food waste as well, same thing. 1 bucket to water, 1 bucket to the food waste. Our system is outside, so the temperature fluctuations are quite critical. Summer, we produce excellent gas. Winter, we've realized that there's an opportunity for a gas blanket or insulator. Yes, that you know the blanket I'm talking about. Yes, so that we keep this big guy nice and warm. I've mentioned this and I'll keep mentioning this, the mindset shift. So because people have come to see what it can look like in urban areas, it has opened up a market for those who are staying in residential estates, in apartment blocks, flats, to explore a system of this nature so that gas becomes an option in addition to the electrical component. And then, of course, the last bit is the local production of equipment is imperative. So as mentioned, this is a module-based system, but there is certainly an opportunity for us to acquire different equipment so that we can enhance the gas output. So whether it is a matter of adding some enzymes, we're still experimenting with that, or certain equipment to analyze the biogas, because if we convert it to our local currencies, the same price tag as a car. So that also opens up those opportunities for us to look at various equipment that we can use to enhance. Right, so operating this functional biogas hub, it has proven to be relatively simple as long as the design is localized. So the material that we are getting because of our location will be different versus what we may do in Kigali, Rwanda, or what we may do in Mzuzu, Malawi, because the material will be different. So it's always imperative that one appreciates what are the socio-economic activities of where that material is being sourced. Then routine monitoring and maintenance are a non-negotiable. I mean, to an earlier point that was mentioned in terms of maintenance and repairs, that goes without saying. It's just like a relationship as well. Every now and again, you need to go on a date and do a check-in. How are things going in life and so forth? Okay, you're meant to laugh so that I make sure you're still listening. Okay, thank you. And then digestate is very valuable. It is an opportunity that we are also exploring. We've currently officially submitted some of our digestate for testing, but we've been using an indigenous way of doing that through our food systems garden, because yes, you can take it to the lab, but nature herself will show you if she likes it or not. If she doesn't like it, she will show you through the quality of plants. And so far we have some butternut, which is bigger than my shoe size. I'm a shoe size 7, and it's a good shoe size 8 or 9 in terms of the digestate that we actually tested out. And lastly, something which I'll keep repeating as well, capacity building for project sustainability. Now, some technologies will die out because you come in, you plug it, and you leave. But in order for it to sustain, you need to have either the staff or community members or decision makers buying into that vision, so that when it comes to maintenance, when it comes to checking in the data collection, you're not chasing people. That's also what contributes to some of these technologies buffering or not always working efficiently. So that capacity building for us has been a pinnacle. Right. The rationale for decentralization is really twofold. One, seeing these digesters contributing to some sort of urban energy hubs. And like I mentioned, there are so many benefits, and I'm really taking a different stance here to look at the benefits and the beauty of organic material. I mean, if you can decentralize this either at a metropolitan or suburban or community perspective and use technology in the form of AI or machine learning, that's how you can re-centralize at the same time, so that you're able to see where the material is coming from, how it's being processed, who is using it for gas, who is using it for heat. So that in itself is excellent. In some cases, you may see that biogas is not the right one. Let's explore biochar because of the organic material available in that particular area. So customization becomes imperative, right? And at the end of the day, because you're able to demonstrate this to not just the ordinary folk, we have financiers who have come to see our activities. Now they kind of sit back and say, okay, about that 2 million euros we can talk, because they get to see, smell, touch, and see what's possible. So the scalability becomes something that is bankable to a greater extent. All right, so our call to action whenever we get the platform to sing the story is really just a case of there is a need for functional, well-managed biogas demonstration hubs, because the demonstration hubs can easily scale into larger systems. And when you show what is possible on a functioning perspective, you can see a whole lot more happening. So the opportunities are there to customize different technologies, because the technologies, like I say, that we're using may not be suitable for Lubumbashi. They may not be suitable for Ouagadougou. But the principle remains that the model in itself is what can be explored. And so as I speak to you, we have a footprint in Rwanda. We are exploring some opportunities in Mzuzu, Malawi, and seeing if we can adopt and how we can adopt this decentralization model into those countries using the feedstock that they have. So all in all, we should be part of the change, and it starts with that mindset shift. And that's the angle that we push through our waste valorization demonstration site. And that is it. Thank you.
Hello, thanks for the presentation. I have a quick question for you. You said the use case was for urban areas. And in the presentation, we saw pictures of the installations, the equipment in the outside. So can you tell us a bit about the user experience? How would people use the power, the biogas for individual use, I don't know, for cooking or whatever? What is the customer journey here? Thank you.
Awesome. We are located, like I mentioned, at a agricultural research council, right? And this council is between 3 municipalities. It's actually in an urban area. So what you're seeing is the farmland setup, but the moment you get outside the gates, you start to see residential estates, shopping malls, and all of that stuff. So on our site, people will come through and we actually demonstrate to them through our cooking processes, whether we're making a cup of tea or we're preparing lunch, frying eggs, boiling rice, whatever the case may be. And this is strategically located because those who are living around our site can actually see that, hey, in my apartment block, we are 28. So if all 28 of us actually start separating the organic material, firstly, it reduces the amount of waste in our 24-liter bins. And we start to see that the recyclables go one direction, the organic material goes into a system of this nature. So we can decide as a state, do we want to use or reticulate this energy into the different households? That's where we also come in and now do the feasibility study of how much waste would be required to produce sufficient biogas for the 28 units to all enjoy the biogas. If it ends up being insufficient, most of the residential estates have a caretaker who stays on site. So that energy can be reticulated to the caretaker's property. If it's not the caretaker, we also have typically some entertainment spaces where we can book for the weekend, Monday to Friday. Kitchen facilities are also offered in those entertainment facilities. So the 28 can also make a decision as a body corporate that we're going to reticulate this energy and it will be used as part of the communal activities. So that's just one example in terms of how seeing it operate on our site can inspire the customization for either 28 units or 200 units and how it can then be utilized within that environment.
Very clear, thank you.
Sure.
Okay. Yes, good afternoon. Oh, sorry, there was one more question there.
Hello. Thank you very much for your presentation. It was very clear and very interesting. My question was, what was the main challenge you have to face through your project? The main challenges?
Do you want one or all 744?
As many as you have. Thank you.
All right, I'll keep it to 3, then we can talk after so that the gentleman also has time. The first challenge is people's mindset. So when we sit here, we know, we understand, we are the engineers, we are the microbiologists, we get it. So it's easy for us to come up with the technologies and the business model. But the mindset of those who need to make the decisions, like the financiers or the property developers, because I don't get it, they'll say no. And that can close up market opportunity. The second is then the feedstock. Separation at source is still work in progress. It's not yet perfect. So now I'm convincing everyone to start separating. It takes a minute because at the end of the day, you want to ensure that the quality and the quantity of your feedstock is sustainable. So this complex or that retailer may be doing it, but we just need more people or more feedstock suppliers to have the same approach to it. And then the final one would be the actual early stage funding. So we committed ourselves, instead of buying McDonald's, we put money aside ourselves and we started it. because approaching funders, again, a bit skeptical because they hear more of the negative stories than the positive stories. So we had to show skin in the game. And thereafter, the conversation started. So, okay, now we see a minimum viable product. We see a proof of concept. We are ready to talk the rands, euros, and kwachas with you. So I'll keep it to those three, but there are 744 more.
Thank you very much.
Sure.
Okay, let me then move on to the other program, Biogas program that we have. So my name is Aart van de Beukel. I represent Safisana. I founded Safisana some more than 10 years ago, but the actual plant that I will be talking about was started 8 years ago. It was the first waste-to-energy plant in West Africa. Initially, we did not even know about that, but it took us a long time to get there. But I'll give you a bit more insight. Upcycling waste for good is the title. That means that we source different streams of waste, mainly fecal, toilet waste and organic waste. And those two are processed in an urban slum of 300,000 people, and in order to make them have a better life and also live more safely. So basically, when I came first to Accra, this is close to Accra, this is what I saw. So this is typically not just for Ghana, by the way, but this is what you see very often, especially in countries that are next to the coastal area, that they are just dumping it in the open. This has slightly changed, improved over time, but still you see this in where we operate, that there's a lot of, well, it's even legal dumping taking place. I read an article from the WHO that 95% in Africa of the fecal is not treated whatsoever. Not meaning that it's dumped like this, but it's not treated. So that's a very high amount. Secondly, this is more a stock picture, but this is the other problem, which is organic waste that ends up on landfills, causing high methane emissions. And it's calculated that about approximately 16% of methane emissions are globally are caused by landfills. This is another picture also close to where we work. And it is another slum area, but you see the combination actually, why I like this picture is because you see the issues around hygiene and solid waste, they all come together. And basically it's a big mess, and it's not a dignifying area, it's unhealthy, and this is not the way forward. So that's where I started, like I said, some 10 years ago, on setting up this idea to build a recycling plant to recover these waste streams and to produce something more valuable, but also not just to do it from me sitting from my office, but also to make them own the processes. So the entire cycle that we run is actually run by the local communities with existing systems in place. So this is how it works. It's schematic. As you can see on the left, we collect food waste, fecal waste. Fecal waste comes from the different toilets from the area, mainly public toilets. And organic food waste is, initially we were struggling to get it. It was initially small pockets of organics, but now more we work with Danone, Unilever, the bigger industries that are interested to have who have a zero waste to landfill policy and would not like to dump their waste illegally and have a proper safe treatment. So for us it's actually a good opportunity because we can combine it, we can mix it with the fecal in order to make these products. And the main ones that I want to talk about is the biofertilizer. It has been discussed here as already. So this is actually a dry biofertilizer that we produce. So from the sludge we dry it and we make the fertilizer. And the biogas is the other output. Currently, we still have a utility contract, sorry. Actually, they are paying. They have been paying now for some 8 years consistently, but we are also looking in other opportunities like producing RNG and then working more with the food and beverage companies. So they have a genuine interest in buying an alternative to LPG that they use for their production systems. That's something we are discussing now, and as you can see, that's sort of where the linear model ends, goes to fresh food and energy products, and actually it's almost like a cycle, but I wanted to make it linear so you can see it like this. So this is the way we look at it. I wanted to also show you this picture because it shows you more the economics behind a typical utility. I was struggling in the beginning to understand. You saw a lot of abandoned wastewater treatment plants, not just in Ghana, and I was wondering how does that work. So I was just trying to make a very basic, simple comparison. So if you look at the capex, the initial investment, plus the running cost of the utility, put them together, and how do you basically cover this cost? If you look at the traditional utility, often they are financed by a DFI. It could be World Bank, could be the African Development Bank, for example, which basically covers the capex. But that's not it, right? Then you have the infrastructure there, but then the operations has to be covered as well. So often they do charge a very basic dump fee, which is, well, almost never enough to cover the entire OPEX. So that's when you see that often these infrastructures, they collapse after even 6 to 8 months or so. So the approach that we have, and this is how we currently do it, is that you have, still we did have some funding received from the African Development Bank initially, but we are able to recover some of that investment because of the mix of sales that we do. So actually we're not just a power supply company, we're not just a fertilizer company, but it's the mix of the two that makes it run effectively. And actually that took us quite a bit of time, right? This is not something you do overnight. The sales contract is a power purchase agreement with the power company in Ghana for actually a good price for 15 years. And the fertilizer now is being sold to distributors, but also the bigger companies are now buying it. And then we charge a recycling fee, especially for the industries that we work with. So with Danone, for example, they pay a dump fee. We call it a recycling fee because we give them the impact report. If they dump it with Safisana, this is the impact that it gives. And that's what they like to see, and they put in their audit reports. So this is just to show you sort of the traditional way of looking at it and the way we look at it in terms of the financials. What we have, this is a picture of the plant we have, where this is the one in Ashaiman. This is near Tema, east of Accra. Currently, we collect daily approximately 60 tons, which is a mix of fecal and organic waste. We serve 75,000 people. This is both from the waste collection side, but also for agriculture in the amount of fertilizer that we can sell. We have a public-private partnership with the government, which sounds like a lot, but actually it was the entry point for us to start in Ghana. But we do most of the work, and actually that's how I prefer to do it. So there is that connection. Access to land is provided by the government. Access to waste is provided by the government, but the rest is up to us. We have a team in the Netherlands that helps to do the technical support, and we step in once in a while to just look at things. But we also have a bit like Sistema.bio. We have meters in the system, biogas flows. You know, we can measure all sorts of things with automatic trackers, and you can see what goes wrong. So that's something we have developed over time. And we are now in the moment where we are building our second factory in the middle of Ghana, in Kumasi. That should be operational in 2 months or so. And we are now want to build it into more like a license model, because we believe that there's a lot of potential here, and the standard is there, and we can scale to other locations. First in Ghana, but then also to other places. Just very briefly on the global market opportunity, I think there are mainly for us, there are 3 key drivers why we believe we can scale in the coming years. Well, the figure I think on waste management is there, 40% increase expected by 2030. Actually, I see it every time I come to Ghana. It's piling up. It's getting worse. Landfills are moving to. There are new landfills coming. So it's a big problem. The second one is demand for organic fertilizers. 5 years ago, I would say that was not the case. There was very little demand, but now they see the advantage of using this type of fertilizer, and the demand is now exponentially growing in the past 2 years. That's what we see as well. And lastly, for us, that's becoming a new strategy to not just work with the food and beverage industries as a supplier of waste, but also to work with them for the offtake of RNG, of biomethane for their systems. And for them, they have quite strict carbon footprint goals for 2035. Some have 2030. So there's an urgent need for them to collaborate with projects like ours. So very briefly, like the roadmap for us, We're still expanding within Ghana. Secondly, more the portfolio development to also look not just at the PPA contract, but also to look at other ways of selling our biogas. And then lastly, to bring it into a license model. And I wrote here broad collaboration, big impact. For me, that's very important. We are a business, but we don't want to work independently. Actually, we need to work with others, with other partners, both in the field, but also in terms of technology providers still, and also off-takers and government. So this is just to give you an overview. And I think that's the last slide. Thank you so much for your attention. Any questions, raise them now or email me. It's all possible. Thank you. Do you take the mic? Or, yeah.
Thanks so much. Thanks, Art. No questions?
Yeah, thank you again for your presentation. What is the amount, the volume of biogas you produce via this 60 ton per day?
Yeah, so the capacity is about 2,500 cubic meter, 2.5 thousand meter. Yeah.
Per day.
Yeah.
And sorry, just based off that question, and the biomethane content?
It's approximately 64%. But this sort of range is between 60 and 65. Yeah.
Great, thanks.
And the biogas is sold to industries or to?
No, not yet. So now we have a CHP, combined heat power generators. So we produce electricity. So the electricity is sold to the grid through the PPA, the power purchase agreement that we have. Yeah.
A quick one for that. What are the size of those gas gen sets that you're running? And are you doing peaking power, or is it just a flat load profile?
Yes, it's a flat load profile, yeah.
And the size? The size of the
2 times 100 kilowatts.
Just to follow up on that question, when you were talking about the CHP, and you also mentioned that it's a public-private partnership, so I want to understand the electricity cost that you know, how do you get to sell your electricity, and how does it fit into this public-private partnership? Because you get the waste from the city, but then you sell the electricity. How does the economics of that work?
Yes, so we don't. I think on the waste side, it's more like we have access to the waste. So it's not that they bring it to us, which would have been more ideal, but we have access to the waste. That's one. But on the price, so we have an arrangement of $17 per kilowatt hour that we get under this PPA, which is for African standards very high. And if we would renew the contract, or if we would expand under the same PPA, it would drop also, it would be lower. So then for us, I think you mentioned it in your presentation, the minimum should be around $10 cents. That is approximately the same that we are using. And again, depending a bit on your cost of sourcing, but 12 cents or something is the minimum we can take for this model. And again, it depends on the size. So this one was designed, initially it was a lot smaller. So this is the bare minimum of the plant that we have designed it for. So that's also, of course, dependent on how the pricing works, etc. Yeah? Yeah,
just on that public-private partnership. So I'm looking at this very similar project in South Africa, near Quebec. It's a large city, a coastal city. And we, again, because the DFIs at NORAD and somebody else are putting the funding in, we get the feedstock for free, and then we put the capex in, and it enables us to create the biomethane or the biogas to then sell through to the CNI industry in that large city. So it's a nice circular economy capex coming in, and we're looking to clean up the water systems and the beaches in that area as well. So, yeah.
Nice.
Can you hear me? Yeah. I am involved in the risk management and insurance on projects like yours, everybody. I wanted to know, in Africa, have you the same requirements from the banks and investors regarding the quality of insurance coverage? And how do you insure it with local market, international market? Just to have you explaining that. Thanks a lot.
Yeah, I mean, what I can say is that there were. So we were partly funded through Dutch government and the African Development Bank. So at that time there were insurances which were more on the initial investment. So as we went on, we have our own insurance package for operations. I'm not sure if that's what you mean, but yeah. So I think I can say that if it could be that the government and the AFDB have other requirements than typical bank requirements. I think, I'm not sure, but I think that could be the case. But that's for me.
On my side, on the larger projects, we have international EPCs like Energia and Veolia. They're getting involved as well, and they're looking to warranty the infrastructure that they're building, that they're putting in place. And especially if it comes with an O&M agreement with these large, big EPCs, then it's easier to insure that as well, off the back of their track record in Europe.
Yes, good morning. Across the presentation, you have exposed to us different models. You have presented to us, Madame, small scale solutions. You are presenting bigger scale solution, mid-size scale solutions. Where do you see the demand and the needs for Africa?
I'll have a quick go, and then I'll pass on the mic. I think the demand is everywhere, to be honest. As I mentioned in my introduction, there's a lot of parts of Africa that we just don't have grid lines from a power perspective, or LPG is being trucked across countries into landlocked countries, or there's deforestation where there's a lot of coal-fired power, coal-fired burning going on in houses. So I think from that perspective, if we just look at the electricity side, if we can put 1 or 2 megawatts down of CHP, and then daisy chain some microgrids to a couple of villages, then we can provide a firm power solution. If we're able to containerize and pressurize that gas and take out the LPG, people having to truck LPG across countries by growing feedstocks or using local plants that have been discussed in this forum, then I think that's another opportunity. And then obviously on the utility scale, on the larger side, having to combat the fact that Sasol and LNG is potentially not going to be an option in Southern Africa and Mozambique, Zim and South Africa. I think there's an opportunity to go to scale as well.
Leeching off what you said, I'll be a bit biased and say 100%. Okay, the opportunities are everywhere, but my interest is in urban areas, right, and the decentralization, while someone else may look at it from a more centralized perspective. So as long as you and I are living and breathing and we are eating, the demand cuts across from small scale to large scale. It's just a matter of what are you picking off the menu.
Yes, I'm looking into small ones, which is, let's say, run by our non-profit organization, Char2Cool, as an add-on on biochar. When I look only in Kenya around Lake Olbolosat and all the artificial lakes for irrigation, we have a lot of Salvinia molesta. This is the small water fern we use for biogas production in small households. So we see in an installation as yours, just from the size, we get with the daily feed cooking gas for 3 families. Because one family cannot use it. Maybe we talk about other applications. Then we talk about thousands of households who could use it and just get the daily feedstock from the Salvinia molesta, and we cannot eradicate it, we just can use it. And as long as all the, let's say, the nutrients from the urban areas go into these water bodies, we have enough feedstock. That's it. Same with water hyacinth. We have around in Ethiopia at Lake Tana 50,000 hectares of water hyacinth. Perfect feedstock for the biogas plants. That's it. So this is one thing, and the other thing I just mentioned a little bit, or the organic food industry, like only this pineapple juice or orange juice, which comes organic product from Africa to Europe. They produce it there. They cannot just replace the nutrients by chemical fertilizer. What they are doing, they dump now the pomace from pineapples, which is really acidic and destroy the soils. It's not a dump site, it's a heap, and that's it. So we have thousands of possibilities, all the tea estates. Let's say, when instead of growing the trees and cutting the trees, it's more profitable to grow grass, Napier grass, and have a cycle with a biogas plant. Drying with biogas is more profitable. And it's always the same thing, as the lady said, mindset. They just go the old bullshit way. That's it. Because one problem is, on the top end, in the management, there are the old men, the traditional men still, and they don't want to change. They don't want to test something. It works, and we don't want to change. It's an easy life. So that's it. This is my experience. So we have millions of applications, as he mentioned, from this, and let's say we have minimum 100,000, I talk all over Africa, 100,000 biogas plants, which are bigger ones for the food industry or mines.
Just quickly, I just wanted to mention the fact that you mentioned Napier grass. So I'm not sure if you're aware that in Zambia at the moment, they only have 3 hours of electricity a day. So Zambia is run on Kabora Bassa, which is hydropower. There's been a drought in Zambia or Southern Africa for a while. So the guys are burning diesel to keep the lights on. They're burning diesel to run their CNI, to develop all the wheat, to run all the mills, etc., etc. And by growing 75 hectares of Napier grass, you're able to produce enough biogas to run 25 pivots. So that's how big the pivots are. They're 75 hectares where they're actually these big circles, and they just can't do them. So if you look at the Google Earth at the moment, you'll see a lot of dry pivots, and that's because they just don't have the power to irrigate them. Where if you had to do it with biogas, you could probably irrigate all those pivots, or you could irrigate 25 of them with one feedstock pivot. Are there any other questions? Yep.
I would like to come back to your 60-ton plant in Ghana. What is the spread of the capex between the recycling cost of the waste, the first part, and the second part, which is to transform the biogas into CHP production? What is the spread of the capex?
You mean how the capex is spread over different? Yeah. I mean, that's difficult to say. I think, the CHP, for example, I think is around 600,000 bit. Then the digester part is about, let's say, 1 million. And if you say about the intake of the waste, that's what you ask about as well, right? So we have intake plots, but we actually get the waste very clean. So we don't have to do segregation on site. So the waste that we get is clean, let's say 95% clean. So there's very little hardware that we use for that. So we don't need waste segregation equipment or something. So total investment of a plant like this is approximately like 2.5–3 million. I mean, this is the bare minimum, right, that I'm talking about. So if we go for higher tech, actually this is one of the things we have really looked at in the beginning to make sure that it's low tech wherever we can. And we bumped our head many times. So we even simplified a few things even more. So because cost, I mean, people have talked about spare parts and stuff like that. I think that's for us, the CHP and things like mixers in the digester are the most sensitive elements that we have in the entire process. Sorry, it's a long answer, but yeah. I can give you more details later, perhaps. Yeah.
Hi, thank you for your presentation. I was wondering if it's in some countries you have like rules and regulations or mechanism to promote biogas.
I'll have a go first. In South Africa, there's no mandate to produce biogas. I think, as I mentioned earlier on, I think the industry is going to have to move towards biogas when we run out of natural gas from the pipelines, if they don't link up the northern pipelines to the southern ones in Mozambique and then through. But as far as I know, there's no biogas protocol. There is an ethanol. We have to produce ethanol in South Africa, which has been mandated by government. And how we do that, I'm not too sure. But that could drive the biogas production as well. I think, just to put a different slant on your question, we don't have legislation on dumping, and I think Aart mentioned that as well in his presentation. Like 95% of the feedstock is human waste in the Accra plant. We've got a problem in South Africa as well. We've got these huge, big wastewater treatment plants that aren't being run properly. So there's sludge coming in and sludge going out, and that's why we can't swim in the beaches in Durban and PE sometimes, and even in Cape Town. So I think it's almost a case of the legislation needs to catch up to say, guys, in order to protect the tourism industry and people on the beaches and people having fun in summer, let's start actually running these plants properly. And one of the byproducts would be biogas off the back of that.
I can only talk about Ghana, right? But in Ghana, in 2011, they have a Renewable Energy Act where they're actually promoting things like what we do, right? So that's why we were actually, like I said, the first one in West Africa to start this. So we had the first PPA, but not active promoting, I would say. There's the law that can do this, but not active promoting.
I'll speak from a slightly different perspective and say there is a growing interest amongst your incubators and accelerators, as well as corporates, with programs such as corporate social responsibility to look at green and innovative projects. So though it's not promulgated as a law of this and a regulation of that, some corporates have to use a minimum of 1% of their revenue to support such initiatives. And you're seeing that drive from corporate to say, okay, let's rather invest in green businesses, exploring tech manufacturing or skills development, whatever the case may be. And there are some colleagues who are also here from South Africa who play in that space of offering that kind of support to small and medium enterprises, ensuring that the sustainability mandate is met in the bigger scheme of things. And I believe from a tax perspective, if I'm not mistaken, Mark, you might correct me, the 12I, 12J, that some companies can be exempt if they are directly or indirectly involved in generally green projects.
Not my expertise, the policy and so on. I have a bit of experience in Kenya. But, okay, just to give a more high level, at the end of the day, governments make our life more difficult, actually, to operate, and it's up to the rest of the organizations that support our efforts. So if we want biogas to be known more, it's up to us, these companies, to promote biogas. The government, I think it's everywhere, almost the same. If they don't see big money, they don't really like to really push towards. So.
If there are no further questions, I was just going to ask one question to the panel, but I think it's been discussed now, is around legislation and regulations.
Excuse me, I just have one question. Thank you for all your presentations. It was really interesting. I'm a marine architect, so I was wondering if in the building industry, if there are already solutions to implement biogas directly in the construction, and if the excuse me for my English, if the septic tank can be changed in biogas digester, if it has already been done, or what are the solutions?
I'm an accountant by trade, but I'll try and answer this one. I know that CO2 is used a lot in the welding process, and once we obviously split the biogas into biomethane and CO2, we have biogenic or bio CO2, which can be used to weld, arc weld. So, welding any steel or anything like that, CO2 could come from those biomethane or biogas plants as well. From a marine engineering perspective, I know one of the big internationals has ordered 16 methane-driven vehicles or driven vessels. The name escapes me now, but they're international, we all know. So guys are moving towards biomethane to run the plants with green methanol, yeah.
She also means whether that has been in the designs of the houses where you have biogas systems installed in houses, right? I think that's also the question. I'm not.
I'm so happy to hear from an architect, because you play a critical role in the early stages of planning in, and that's what I did my doctorate on. How do you plan in? How do you design in these decentralized systems from inception? So I'll give you a practical example, which I shared with the gentleman earlier, that when it comes to, let's say, a residential estate, right, one needs to design in waste separation right from inception. And when you do that, it's a case of who will be the off-taker for this various material once we've separated. And it becomes a regulation or part of the body corporate to actually say this is what we're doing. Alternatively, if it is one of those large-scale international companies that set up shop with 10,000 people in a building, it can also apply that everything that you eat from the cafeteria or from your lunch boxes at home, this is where you need to dispose of it. So it becomes company policy. And once that's done, it creates an opportunity for technology such as biogas to be presented at a decentralized level. So whether you're looking at it from a property development perspective, you as the architect are now part of the technical design in terms of what the separation looks like and where the processing can take place. But you'd be working hand in hand with the chemical or the microbiologist or the mechanical engineer to ensure that the principles of both architecture and engineering are taken into consideration. From an architectural perspective, again, it has to blend into the aesthetics, because the last thing you want is to have a half-shaped looking thing that makes it discouraging for either the office staff or the residents to participate in the separation and the processing activities. And this can be designed in an aesthetic way that you don't have to see the biogas system directly, but even if you do see, it doesn't shock you off your feet. So those are, I can tell you, conversations that we've been having as well, early stages. But again, the mindset of the property developers, like, it's not affecting me. And the mindset of the architects, I don't get it. So it's a journey, let's put it like that. It's a journey. But your interest indicates that there could be dreams you have tonight, and then you find yourself in our space offering that as a niche service from an architectural perspective. Thanks.
Yeah, and I think to Gami's point, I think it's with the fact that we're running out of land space for additional dumps, for additional agricultural waste, etc., we're going to have to start thinking along those lines as well.
I want to, that's a brilliant idea why septic tanks are not really used, but the reason is septic tanks, normally they take a lot of soaps, it's grey water, it's human waste that at the end of the day is going to be very hard to turn the septic tank into a very good performance anaerobic digester, because there is a lot of things and it's not going to be very easy to produce really biogas out of this.
I did have a question, but it's more on the legislation in respective countries where you guys are working. Do you see new legislation or rules and regulations coming up that would promote the cleaning up of water systems, promote the cleaning up of sewage systems, etc., which could lead to additional biogas infrastructure projects being built?
Yeah, I know at the moment when we don't look to Africa, to India, where there is a policy they want that 6,000 new biogas plants for CBG, compressed biogas, let's say CBG biogas plants, which has the smallest one, let's say, in the range of 1.2 megawatt electrical equivalent or so, or 5 tons of CBG per day, the smallest and everything. So India wants to become more independent from import and say, let's say, maybe in South Africa when the natural gas wells run dry, maybe they could look into the Indian legislation. India gives 25% to, let's say, capex funding, but not prior to construction. After 2 years, they see it now, when they see there is the performance, then you get the subsidy. And they see now from 200 already built plants, only 190 failed and never achieved it. But so they get only, let's say, when they get from, instead of 5, only 2.5, they get 50% of the funding. So the investors and the EPCs are now under pressure to deliver a real good quality. And they have a scheme now that digestate is sold as fertilizer. So they give a market support, which is per cubic meter per ton. This is 15 euro, which is a lot of money. So means it's a support. So but this does not, let's say, go for all the 6,000 plants, but now for the first 2-3 years until the business or the industry is established. So, and now how to say, the production of CBG is going now exponentially.
A slightly different approach. I say, look, chicken and egg situation. Do we wait for policy to be amended and regulations to be sorted, blah, blah, blah? Or can we also turn our focus to small and medium enterprises, cooperatives? Because at the end of the day, they're the ones who are doing the stuff on the ground. They're the ones who are disrupting. They're the ones in the labs. They're the ones outside exploring what's possible and what's not possible. Because that in itself, the more we see them popping up, the more it can also work towards influencing either amendments, policy amendments, or new policies and regulations. Because within the South African environment, there are 1 or 2 policies that are from 1947, which are not applicable to me. So we are in 2026, and it's still a relevant policy. I mean, must I stop? No, we must not stop, and 10 other entrepreneurs must not stop. But let the work of our hands then inspire that 1947 to have a 2026 amendment to it. Alas, we'll keep waiting. Thanks.
The next question I had was just on project finance. So I'm not sure, Aart or Walter, you mentioned the DFIs, but are there any commercial banks that would be looking to finance the project that you guys are working on in your countries? Any other commercial banks in country that would be looking to put some skin in the game?
It always depends who is the customer. When I'm EPC, when the customer is a strong company, you always need 30% equity, sometimes only 20, but then the rest is loan from the bank. And the problem with different countries is when we let's say in India we have now, I think 6-7% interest rate. In Germany we have 3%, but when we go to Africa we have 10, 15, 20%, and this breaks it. So what I'm looking for is now we have so much money in Germany. So I ask my friends from the biogas industry or biogas farmers to invest in these projects because the profit margin is so high in these countries that they cannot even imagine how much a profit is, because we payback period, we talk about 10, 15 years in Germany. So no African investor would touch a project with 10, 15 years. It's even 3. They don't want to touch it. You can imagine how much profit it is in these countries. So I invite my friends to bring equity in it to reduce the loans and reduce the pressure of the high interest rates in the local countries. And it's not easy because we still have the picture that people, most of the Africans, let's say 95% of the Africans still live in the mud hut. This is the picture they show still on TV in Europe. And that's it. So the people say, okay, I cannot invest. And that's the big problem, mindset. That's the big thing, again and again and again.
Yeah, just a small comment as well. So I think the real commercial will not be so keen to step to us. I mean, the banks we speak with are more development banks. They have more patience. They can do capital with a repayment of 10 to even 12, 13 years. For us, that's perfect. And I think the other thing that they want to see is that there's consistent supply, so supply contracts and offtake contracts. These two are key. And that's why we are now getting in that stage where we can start attracting this kind of investments. But so far, it has not been possible. And secondly, the government in Ghana, if they would only pay, let's say, €5 per ton treated, we have a massive commercial case. And we have a much more interesting case for banks as well. But the thing is, they're not going to fund that. And it's actually, that's a bargain for them. If you compare to Europe, waste treatment, it's much higher. So... but I mean, that's the reality, right? We are not going to change that. That's what I see.
Yeah, I think just to that point, we have so much land available. That's why I mentioned we could grow feedstocks like Napier grass and the cactuses for the biogas, but at the same time, the reverse is we've got so much land available for people just to dump. And illegal dumping is obviously huge.
Other thing is, so in Malaysia, and now we were asked to produce biogas from the, let's say, byproducts of palm oil mills. And no one was interested, but now the demand only from Singapore is 9 million tons of LNG, bio-LNG. And there are around 1 million, I think, 1,000 cargo vessels are on the docks to build for, let's say the fuel is LNG, bio-LNG. And the production of biogas is not yet in place. They built already the liquefaction plants, or one at the Strait of Malacca, but have not 1 cubic meter of biogas. It's always the story, you know, when you have assigned to have a monkey recite a poem on the pedestal, they built the pedestal first. That's the problem. They build now the liquefaction plant, but not the monkey biogas plant. That's the big problem now. But when we look into South Africa, so, and you have plenty of land available, this is one, let's say, sector to produce LNG for the marine ship, so let's say for the vessels.
I don't have any more questions. I'm not sure if there's any in the audience, but we're almost time's up. Thank you for listening. Yep. I don't have any closing remarks other than we're open for business. We're looking to do more biogas in Southern Africa and Africa. I think it's going to be a good story, and hopefully in about 10, 15 years' time, there will be a lot more operational plants, and I'm looking to hopefully take out the LPG market with with CBG. So let's see what happens.
Thank you.
Anyone else?
Thank you.